Hello, welcome back to the Joy of Code. This is Michael here after a break of a couple of weeks or so. We will do a lot of new stuff today. I haven't really thought this through very much, so I will be live coding and see whether I can get this done. I haven't really tried that out before, but I wanted to get another episode out because I know some of you have been waiting for it. What we want to do today is we will get a counter on screen here where we can see the score of the game. You can use this for the turtle game, and I will use the turtle game, or you can do that with any other game you might write. Getting a counter on screen is of course a very common thing that we want to do. I'm doing that for two reasons. First of all, I've been asked many times how to get a counter on screen. It's a very common request, so I'm going to show you. But also I have started talking about object interaction in the last episode, and this is another really good example of object interaction. But it's actually quite an advanced one, so pay good attention. I have here a counter class already prepared, so we will do this by using a pre-made counter class rather than writing our own. We will look in a later episode into how you actually implement a class like this, but for now we will look at using a class like this. This is a class called counter.java. We will get this into our project by creating here a new subclass called counter, which we then get here, and then just copying the prepared code into this code here. So I'm opening my counter class that I've just created, and I've got the default skeleton code here, and I select this and delete it all. Then I'm opening this counter class here that I've got on my desktop and that you can download from my blog site and the entry for this episode. So you can download this, open that in the text editor, select everything and copy it, and then you go back to the Greenfoot editor and you just paste the whole thing in here. So now you have your counter class in here. Then I'm setting the image. I'm going to do a set image, and see here on the desktop also I have my prepared image. It's not in the library here, so I just say import from file. I'm going to my desktop and there I select my counter image, and there it is, and say OK, and now this has an image. And I can compile this. There is also a Trick the Turtle project downloadable from my blog. That's Trick the Turtle version 4. That is in this state exactly as it is now. That is with a counter class included, but no other code written yet. So you can use that project as a starting point if you want. Let's look at what it looks like. I can now create a counter, and if I put that somewhere in my project, this is what my counter looks like. So here I've got a counter object. If I look at the methods of the counter, I have an act method, then I have here three other methods: add to the score, or get the current value, or set the value. So if I say I want to set the value to 45, then the value changes to 45. So I can set the value. I have also, oops, sorry, I meant to call the method here. I can show you the add method. The add method has a sort of slight animation. So if I say add, and I add to the score, and I add, say, 50 points to it, and I say OK, the value here doesn't change immediately, but rather when the scenario runs, it counts up to the value that it should be. So there's this sort of slight animation effect that if you change the value, it doesn't change in one chunk immediately, but you see it counting up. So there's the counter. That's the counter object we want to use. Now what I'll talk about today is how do we get that into a project, and how do we make it actually count. Because now, of course, when I run my project here and I have my turtle and I eat my lettuce, there's nothing at all happening here in the counter yet, because my project doesn't actually use this counter yet. In fact, as soon as I reset this, this counter is gone. My project doesn't even create a counter object automatically. I've just created that by hand before. So the first thing we'll do is we get the project to create a counter object. So we look into the turtle world class. I open the turtle world, and in the turtle world here is a constructor. A constructor is a special method that gets called automatically when an object is created. So when the whole world is created, this constructor is automatically executed. A constructor is quite similar to a normal method with a few special characteristics. First of all, the name of the constructor is always the same as the name of the class. That is in fact what identifies it as a constructor. So if you have a method that you name with the name of the class, that is a constructor. The next thing is a constructor has no return value. We have always seen that other methods have the word void or another type between the word public and the name of the method. A constructor never has a return value because it doesn't return anything. It cannot return anything. So this constructor here is called automatically when the world gets created. And here it calls what's called the superclass constructor. This specifies the size of the world, and then it calls a method called prepare, which is defined here. And prepare creates all our objects. It creates the turtle object, and then it creates all the lettuce objects that we want, that we have here in the world. And somewhere at the bottom here it creates all the snakes and the bugs. So that the prepare method creates all the objects. Let's say I want to create a counter as well. I can write here counter, and so I'm creating a local variable here. I'm defining a local variable of type counter called counter, and I'm creating a new counter object. And then here I say add object, that is this new counter object that I've just created. I'm now adding it to the world. I could have done that as before by manually creating it and then doing save the world, but this time I want to do that manually. I want to actually write the code manually so that you understand exactly what's going on here, so that you understand there's actually nothing magic going on here in the prepare method. So add object is a method of the world class that takes 3 parameters. It takes as the first parameter the object we want to add, that is the counter, and as the other 2 parameters it takes the coordinates where we want to put it. So let's say I put that at 100, 100 as the first approximation. So this is measured from the top left corner of the world, 100 pixel over, 100 pixel down, 100 pixels. Okay, so I have created a counter in my prepare method, which gets called automatically from the constructor of the world, and I add the counter in the world. So if I compile now, a new world will get created, and there is my constructor automatically created and inserted. Now the location of the counter I don't actually like very much. It's not positioned very well, so I want to move that somewhere up here. I can do that quite easily by manually moving it up here where I want it, and then I right click on it and I inspect it and I check what its current x and y coordinates are. The x is at the moment 58 and the y is 26. That's good, so that's what I want to use, 58, 26. That's what I do here. I place it as 58, 26, and I compile, and my counter will now always be placed there. Okay, so I have a counter in the world, but so that gets programmatically created and inserted. But when I run my program and I eat my lettuce, still nothing happens. So now we need to make the counter count. At the moment in our turtle we have a counter here called points as an int variable in the turtle, and whenever the turtle eats some lettuce we're getting points, and when we eat a bug we are getting points, but that is not reflected in the counter. So instead of counting in our int variable, we don't want that anymore, we actually want to count in our counter object so that we see the score on screen. Now the problem is that here the turtle knows when to count. It knows here at that point I want to add a point for my counter, and so the turtle knows when I want to count, but the turtle does not have access to the counter object. The counter object is the one that actually holds the count. Now the turtle, when it eats the lettuce, the turtle needs to tell the counter to add some points here. Well, the problem now is, how does the turtle talk to the counter object? At the moment the turtle does not have a a reference to the counter object. That means the turtle object doesn't know the counter object. We can look at this sort of graphically. The turtle is an object. So let me draw that here. Let's say, oops, I need to get black paint. So here, this is my turtle object. I write a T in here for turtle. So if that's my turtle object, and I have here my counter object, that's my counter. The turtle can only talk to the counter if the turtle has actually a reference to the counter stored, but it doesn't. What actually happens is that we have a world object. That's my world. The world object gets created. The world object creates the counter object, and the world object has a reference to the counter object. So the world object is the one that creates the counter. Then the world object creates the turtle. So the world object has, the world knows the turtle, the world knows the counter, but the turtle doesn't know the counter. So in order for the turtle to tell the counter object to count up, the turtle must know the counter object. So what that means is that we have to tell the turtle the counter object about the counter object, or in more technical terms, this arrow here that I have drawn here, that's called a reference. The world has a reference to the counter object, and that is in our code represented here by this variable. When we say new counter in the world object here, the world object gets a reference to the counter and it stores it in this counter variable. At that moment, the world object has a reference to the counter stored in its counter variable. And then when we go back here, when we go back here, the world also creates the turtle and stores it in a turtle variable. At that moment, the world also has a reference to the turtle variable, to the turtle object. But now the turtle, when it runs and when it eats some lettuce, needs to tell the counter to update the count, to add some points here. And the turtle cannot actually see the counter. So what we're doing is we're passing the reference to the counter to the turtle, so that then the turtle also has a reference to the counter, so that the turtle can tell the counter to add some points. That's a new thing that we have to do here now. So to do this, we have to, when we create the turtle, we have to pass to the turtle the counter reference. So I can do that actually by, when I create the new turtle, by passing the counter reference as a parameter to the turtle object. So when I create a new turtle, they have always been the two round brackets for a parameter list, and we haven't used the parameter list before. Now we pass the counter object. This will not work currently. At the moment, if I try to compile, I will get an error somewhere. We'll say here that doesn't work. It can't find a constructor of this kind because the turtle at the moment has no constructor defined to receive this parameter. To receive this parameter here, I now need to write a constructor for the turtle. And remember, I just said that before, the constructor is a special method whose name is always the name as the class. And here, the constructor has a parameter list. And now, here in the parameter list, I can write a parameter list that can receive the counter. So I say here, I want to what do I call this? I call it the world point counter. So I have here now a parameter to the constructor of the turtle that can receive this counter. If I now try to compile, we will see everything compiles fine, because now the counter gets created, then the turtle gets created, and the turtle gets passed the counter object. So we have now a situation that is almost like this, except that the turtle, it receives this arrow to the counter, it receives the counter reference. It hasn't stored it yet. The turtle must store this counter object. Now here in its parameter it receives the counter, and now when the constructor finishes, this parameter will just disappear. So we haven't done anything with it. What we will do is we just want to hang on to this reference to the counter, and we do that by having here a field where we store the counter. So we have private, I make a field that I call counter, and here I write counter is assigned point counter. So what I'm doing here is I'm taking this parameter and I'm assigning it, this is an assignment symbol, to this field that I've declared here. So I'm taking the reference to the counter and I'm storing it in my field. The reason I'm doing that is because the parameter will disappear in a moment. As soon as we reach the end of this constructor, the parameter will disappear, but the field will stick around. By storing the counter reference into my field, I now have permanently stored a reference to the counter. Now I have this situation that I have here, where the turtle has a reference to the counter, and the reference to this counter is stored in this variable called counter. And now I can use it. So when we actually get some points here, instead of counting the points in the points variable, I want to remove that. Actually, I don't want to use the points variable anymore to count it. Instead, I want to use the counter for my points. Where was it? Here. Here I want to say counter dot, and then let's look at the counter methods. Add a score is the method I want to use, so it was called counter dot add. Let's give ourselves 5 points for a lattice, and then here counter dot add, and we give ourselves 20 points for a bug. So we are adding 5 points here, and we're adding 20 points there. And here we have used the points variable before to check whether the game is over. Now here we need to use the counter as well. So we say counter dot, let me see, get value is the one that gives me the current value. If, say, the counter get value, the current value of the counter is 80 points or so, then game is over. Actually, I had a bug there before. I should say if it's greater or equal to 80 points, so not to not repeat the same error that I introduced last time here. Okay, so if our points get over 80, let's try that out. Let's see whether that works. I haven't actually tried that before. So now there's our counter, and now let me just close these here. And let's watch it. So, yep. And if you watch the counter, you see, and the bug, I can try to catch the bug. That should give me, yep, 20 points. And there we go. That works. There is our counter. So I'll leave it at that for today. That is a lot to think about. Let me just say again, I have introduced 2 really, really important concepts today. One is the concept of a constructor that we will see later on again. And I should actually write a comment here as well and say create a new turtle with a reference to the counter in the game. Okay, but more importantly, what I have introduced, and that is maybe the most fundamental concept of object-oriented programming, is the idea of objects talking to each other, where we have a network of objects, where we have here several objects involved. I have drawn 3, but of course there are many more objects. There's all the lattice objects and the bug objects and the snake objects as well. But we have focused on 3 of them, where one object holds a reference to another object, and it can talk to the other object only when it has a reference to the object. And we can pass these references around, and so the turtle class receives a reference to another object, to the counter object, and then stores it in a field so that later here it can talk to that object, and it talks to that object by using the variable where it stored the reference, then a dot and a method call. So here we're calling the add method on the counter object. Essentially we're saying to the counter add 5 points to your value. This object interaction, objects talking to each other, is the most fundamental idea of object-oriented programming, and we will see much more of it, and you have to come to understand this properly. Okay, that's it for today. Until next time, bye bye.